Hello everybody. Welcome to the breakout session on environmental racism and inequalities in urban heat islands. I hope you have found the conference worthwhile up to now. And if you were part of the previous panel session, a follow-up here on the issue of heat and inequalities around that topic are highly relevant now to this breakout session featuring Dr. Angel Xu. So I'll introduce her here, and then she'll take the floor for 15 to 20 minutes. We'll have a few minutes for follow-up questions, and I think both Andrew Whalen and I can monitor the chat for Angel. My name is Andrew Harver, and it's been a real pleasure working with the CAC team to put together this NC Breathe 2021 conference. So Dr. Xu is an assistant professor of public policy and the Environment, Ecology and Energy Program at UNC Chapel Hill. And she is founder and director of the Data-Driven EnviroLab, an interdisciplinary research group that innovates and applies quantitative approaches to pressing environmental issues. Her research explores the intersection of science and policy and the use of data-driven approaches to understanding environmental sustainability, particularly in the areas of climate change and energy, urbanization, and air quality. Her research projects apply large-scale data sets derived from satellite remote sensing and other spatially explicit sources to evaluate environmental policy performances. And we can see one of these images right now, I think.
That's right.
She holds a PhD in environmental policy from Yale, a Master of Philosophy, and a master's degree in environmental policy from University of Cambridge, and started her undergraduate career in biology and political science at Wake Forest University. So Dr. Xu, we're pleased to see you. Welcome, and we look forward to your presentation.
Thank you so much for that really kind introduction. And yeah, this is a coming home for me. So I grew up in South Carolina, and then I went to college in North Carolina. So when UNC came knocking on my door and asked me to come home, I said yes. So on a more serious note, I'm really looking forward to engaging with you in this breakout session to talk about an area of research that I'm becoming more and more interested in, which is the phenomenon of environmental racism and disparities in access to environmental amenities like, for example, and protection from urban heat, and also access to amenities such as sustainable transit, for example, and green space. And so I have been watching from afar. I was living in Singapore the last few years and seeing the Black Lives Matters movement unfold, and just feeling like, as a researcher of climate change and data, how can we actually get data to make these disparities visible? And so that's where I want to start today. And so going to my next slide, if I can get Zoom to cooperate with me. You may have seen this New York Times interactive last year that came out talking about how decades of racist housing policy have worsened the climate change crisis. And so researchers in Oregon and also in Virginia have developed this database and this mapping exercise looking at historic redlining policies, which actually helped mortgage lenders risk, and as a result excluded, largely based on race and ethnicity, populations from accessing mortgage and housing loans to live in more desirable areas within cities. And so the legacies of these policies have now translated into some of these neighborhoods being de-invested within, or having less tree cover, for example, or environmental amenities. And so while studies like this have provided small-scale evidence of environmental racism, so when people are living in more densely populated areas, they may be more prone to exposure to air pollution, for example, or not have access to green space and more shade and tree cover provided by having more green space available, or they may not have access to sustainable transit, for example, bus options and other types of public that would allow them to drive their car less. And so there have been anecdotal evidence, but one of the questions I was interested in asking is, are these patterns actually persistent and pervasive? And do they also translate across a range of socio-demographic factors? So not just looking at race and ethnicity, but also age and income. And how can we use data and the revolution in data, large-scale data sets to actually try to answer this question and investigate whether or not these patterns are actually widespread and pervasive? And so we can do this now due to the increase in satellite data that is now available. So there are two main ways of measuring urban heat island intensity and exposure to urban heat. And so when I talk about the urban heat island, I essentially mean the difference in urban temperatures compared to a rural or a background reference. And so you can see I have different land cover types in this image. The night and daytime temperatures in rural areas is much lower than those in the urban core. And this is largely due to the fact that urban areas have more impervious surfaces. They've converted natural landscapes and forested areas to built landscapes, to concrete, asphalt, cement pavement, for example. And that has resulted in urban areas being much hotter than these natural surrounding areas. So this gradient between urban and rural temperatures is referred to as the urban heat island. And there are two ways generally to measure this. One is at the air canopy level, and so getting temperature data from air monitoring stations, for example, weather stations. But then with the advent of satellite data, now we can actually systematically, globally measure land surface temperatures using satellite remote sensing. And so there are some differences between these measurements, but the great advantage of using satellite data is that it's widely available. You have satellites that are rotating the globe consistently on a daily basis. And so we can now leverage this data to start to examine if these patterns are actually systematic and widespread. And so we used data from NASA satellites, and we're able to develop this global particular explorer for the United States. So we evaluated urban heat island intensity using Google Earth Engine and MODIS data. So this is one of the satellite sensors that we use for all 490 at the census tract in the United States. And so that's what you see here on the left, surface urban heat island intensity. And so how much the urban core is hotter than it would be if it was not paved and impervious. And then over on the right, we have demographic data. So what percentage of each census tract, for example, is Black or white or Asian or Hispanic or Latino, for example. And so you can explore all this data systematically. So what did we find? This study is hopefully coming out very soon, but the preprint is also available. I'm happy to share that with anybody after this session. But these are basically data distributions of exposure to urban in all of the urban areas that we examine. And so you can see here that in most major US cities, populations in red are exposed to higher urban heat island intensity than populations in blue. So we compared different demographics in these different histograms here. And so you can see that in almost every single case, the red population is exposed to higher temperatures on average, so higher urban heat island than those in blue. So people of color, people living below poverty are exposed to, on average, higher urban heat island than their white counterparts. And so this actually translates to almost a full degree Celsius more than their white counterparts when we look at communities of color. But another finding is that exposure patterns are virtually identical for people living below poverty and communities of color. So whether you're socioeconomically disadvantaged, times below the poverty line, or you're a non-Hispanic white person, your distributions in your likelihood of being exposed to higher urban heat island is virtually identical, which we can see in panel C. In terms of age, what was really interesting is that even though there's a lot of data, so about 39% of heat-related mortality in the United States happens in population 65 or greater, we actually didn't see that there were major differences in the distributions for populations under 65 or over 65. And so that's panel F. You can see that those distributions are pretty similar. But then, of course, when we look and break that data down further by race, some of that same pattern exists where populations who are over 65 and also happen to be of communities of color are exposed to higher urban heat island. But if they are white, they are also exposed to less urban heat than their counterparts. So we can also take a look at some of the spatial patterns of these differences and these inequalities in exposure. And so what we found is that in 97% of major US cities, they're exposing communities of color, minority populations to higher urban heat island intensity than to white counterparts. And so that's represented here in the triangles. And then we outlined the triangles where these differences are actually statistically significant. And really, there are only a handful of cities where we're seeing circles. And so McNally, Texas, for example, which is at the tip of Texas, that is one of the few cities where white populations are actually exposed to more urban heat. But when we dug into that particular city, it actually turns out that they don't have that many populations that are considered communities of color by the US Census. And so, and then also the size of the triangles also corresponds to the magnitude of that difference. And so what was really surprising is actually in the upper northeast of the US, where I was previously living, some of those disparities are actually much greater in magnitude than in other parts of the US, like some parts of the central US. I'm looking at Arizona, for example, where you would think that some of these disparities would be much higher, but actually in the northeast, it's actually more extreme. And so we saw similar patterns, again, as I mentioned, in 94% of major US cities. Living below poverty, 2 times below the poverty line, are also exposed to higher urban heat island intensity compared to those who are living above the poverty line. And then also we see that for populations of color and those living below poverty, it's roughly equal in terms of their being exposed to higher urban heat islands. So these were some of the main findings from our study, which should be coming out now. But again, I'm happy to share the preprint. And then just to dive into some specific case studies, what we also found is that the patterns of exposure vary by city. And so they're not the same depending on where you're located. So this is my hometown of Greenville, South Carolina. And we can see here that the hottest areas in red and orange within Greenville are coincident and overlapping with populations of color and also people living below poverty. And so there you have those populations actually overlapping. So those living below poverty, the highest census tracts with the greatest percentage of those living below poverty overlap with the hottest areas of the county. And then also the percentage of Black population, the counties and sorry, the census tracts that have higher percentage of communities of color living in them happen to also overlap with the hottest parts of the city. But then if you look at Baltimore, Maryland, for example, those patterns are actually quite different. So again, the hottest areas of Baltimore happen to be in the downtown core, but then the Black population is actually more dispersed and not just all concentrated in the urban core. And we see a similar type of dispersed pattern for those living below poverty. They're much more scattered, but you do see some concentrations in the downtown area. And then in terms of greenness, so we measure that again through satellite remote sensing, we can see that some of the greenest areas in dark green happen to be in the outer fringes of the city and less greenness in the downtown core. So those seem to mirror the hottest areas of the city. So I was asked to talk about not just the problem and documenting these inequalities and showing for you that the data and the patterns that exist that we established through our analysis, but also to talk about some solutions. And so, for example, here you can see very clearly that there's a relationship between urban heat island and also greenness. And so trees, they can provide some protection against urban heat by providing shade, for example, and that also enhances evaporative cooling. Trees also can filter out harmful air pollutants, for example. So by providing more tree cover and by planting more trees, we can be combating the urban heat island effect and climate change effects, but also air pollution as well. And then there's a host of social benefits that green spaces are also known to provide, such as providing social cohesion and also safety, for example. There's literature that suggests that parks and green spaces also tend to be some of the safest parts of an urban area. So my team has also developed this Urban Environment and Social Inclusion Index. You can access the project here on the bottom, datadrivenlab.org/urban. So for 165 cities around the world, we have this interactive dashboard where citizens and city planners and decision makers can come and look at some of these disparities side by side. So this is Los Angeles, for example, and then you can see income by neighborhood on the left, and the darkest green neighborhoods happen to be some of the wealthiest. So over 100,000 US dollars per person. But then on the right, you can see that tree cover percentage for those dark green neighborhoods happens to be well over 70%. And then the much poorer neighborhoods in blue on the left, so you can see some of these down here. I don't know if you can see my cursor, but I'm circling some of these blue neighborhoods have about a third of the income per person, so around $30,000 per person, and only about 5%. So they are highlighted in white here. So I think one of the possible solutions is through data, and by harnessing the data revolution and satellite remote sensing, we can develop tools like this to actually map these disparities and to show citizens and policymakers that these differences actually really exist, and they translate into different health incomes and different disparities when it comes to health. And so this is Charlotte, North Carolina, for example, in our dashboard. And you can see tree cover, for example, some of the greenest areas of Charlotte, North Carolina happen to be in the Southwest. And those happen to be some of the coolest areas that you can see by measuring the urban heat island. And some of the hottest areas in the downtown core also happen to be those that don't have tree cover. So by pointing out these disparities, by making policymakers aware, they can then design policies to encourage tree planting or subsidize tree planting, increasing of green space and parks, and trying to make the distribution of those amenities more equitable for citizens who need it and who are already at a disadvantage. And so that's one of the key policies. The researchers that were featured in that New York Times article, I went to their website, which is also available at the bottom of the slide, and they have included these historic redlining maps as part of their data project. And so I found it really interesting in terms of looking at these different redlining policies and practice, and how different areas within the urban core were graded best, still desirable, definitely declining, and hazardous, and how that's also translated into existing disparities in urban heat island exposure. And so a lot of these mapping tools, I think, if we could bring them together and make policymakers and citizens aware, I think could raise a lot of awareness of where resources could be better directed in order to counteract some of these differences. And so this is some of the photos that they highlighted as Times article. So this is two different neighborhoods in Baltimore, and you can just see in these street level photos, just a wealthier neighborhood has all of these lush trees, and they could have selectively chosen where to take these photos, but I think it's indicative of some of the problems that cities are facing. And you can see in this top photo much more pavement and far fewer trees. And so now cities like Minneapolis and Portland, for example, are working on zoning policies to allow for denser and more affordable housing to be built in some of these more neighborhoods that were previously excluding lower income residents and also communities and people of color. And then Denver, for example, in Colorado, has passed funds to earmark particular resources for tree planting and for green spaces and parks. And then some cities like Houston, for example, have passed laws and ordinances to try to prioritize disadvantaged neighborhoods for flood protection. And so you can see that we could also encourage policymakers to try to identify some of these disadvantaged communities and think about policies for how to better protect them. So these are just some ideas, but yeah, be really your ideas of how we could take some of this data and actually translate it into policies and actions to address these inequalities and systemic environmental racism that now we have data to show exist on a widespread level. So thank you so much, and hopefully we still have some time for exchange.
So impressive, Dr. Hsu. And as you try to multitask here, which apparently you're very good at, if you could pop the link to this preprint that you mentioned might be available into the chat. A few people have already asked for that.
Okay,
so
yeah, I can do that. I'll Google that. Try to get out of, I'll stop sharing my screen so that I can actually
sure. So we do have time for a couple of questions, and as people think about their follow-up, first of all, this mapping technology is just so impressive. And you show these slides with these, very powerful implications. And I know that you just don't take a picture to make that happen. This is very labor intensive activity. I appreciated those maps. Those are fantastic. And I appreciated even more your examples, which were very local. Greenville, Charlotte, Durham. I'm pleased to see that Jennifer Roberts is part of the session, and maybe she can follow up on this as well. You might know that there's this crescent of inequalities in Mecklenburg County. And isn't it moving that so many of these metrics all seem to move together, right?
Yes.
Higher rates of poverty, lower rates of education, and now apparently lower amounts of tree canopies. So I was going to ask you about the canopies, but you raised that issue. And just before I stop blabbing, I did have one question though. A lot of your data turned on population. Have you also considered, or maybe this is not relevant, density? Is there something different about population density? And I don't want to be superficial when I think about the history of the so-called inner city, right? Which I kind of felt with some of the maps that you showed, in terms of the disproportionate number of Black and brown people that historically might have been, pushed into, these urban centers.
That's right.
So,
yeah.
So my real question is about, is there anything different about population versus density?
Yeah, that's a great question. And there was a study that was published, I want to say in Nature or Science, and Manoli et al. Is the study where they actually did population density is a very strong predictor of urban heat islands. So yes, that's absolutely correct, where they have found systematically on a very large scale, again, using satellite data, that population density is highly correlated with the strength and the intensity of urban heat island exposure. So yeah, I mean, I think that then the question is, well, what do you do with that information? And I think in preparing for this session, and I was really pushed to talk solutions, which as a researcher, we often don't get the luxury or the opportunity, and we don't have the expertise to really think about that. But so I've been so intently focused on the data and the method, and that's where, I mean, I would love to hear from others in the room, like, well, what do you do with that information? Because you can't de-densify some of the, right? I mean, because for other environmental metrics, such as carbon emissions, for example, you actually want that density. Like New York City is one of the most population dense cities in the world. And as a result, they have some of the lowest carbon footprints than anyone else. So there are a lot of these trade-offs. So even though I think a lot of these indicators track similarly, there are still these trade-offs. And so from a planning and a policy perspective, yeah, I would be really curious to know from folks who are actually on the ground making these decisions and these policies, well, how do you weigh those trade-offs?
Let me ask Jennifer Roberts to share her experiences.
Yes, thanks. And this has been a terrific presentation. I was mayor of Charlotte for one term and a county commissioner for Mecklenburg County for 4 terms. And we have done the mapping, and we have seen the correlation in the hotter areas, more aggression and violence on hot days, more police calls, children don't learn as well, the income levels, I mean, everything, health disparities and chronic illness, I mean, it all matches up. And the challenge that we have is, the different levels of jurisdiction. We have a city, we have a county, we have a school board, we have a state government, we have all these different players who don't always coordinate. And we have, a political environment that doesn't want to spend money. But we know the challenges that are there. And, we have a Tree Charlotte, we have a Sustain Charlotte, we have a strategic energy action plan the city has put together to try to reduce greenhouse gases and deal with a lot of the disparities. So this kind of data is really important. In fact, I'm one of the ones who said, please let me see a copy, because we think if not just the policymakers are armed with the data, but if people in general understand, EDF did that survey not too long ago that said 63% of white people don't know what environmental racism is or environmental justice. And that continues to be a challenge. Once we see these connections and understand that these health disparities are real and that, Black children are 4 times as likely to die from asthma as white children, when they know these are real facts, then the policymakers are moved because they get pressure from the community as well. So thank you so much. I look forward to having all your data.
Yeah, that's really interesting. And yeah, I think the feedback I've been hearing from a lot of cities that I speak with is also the challenge of trying to just coordinate so many different players and different policy goals, and it just, yeah, it's very complicated. So it's really interesting to hear your perspective. And yeah, I'm actually really encouraged that you think that the data can make a difference, because I also hear a lot of skepticism where people say, well, if you provide the data, it's not enough to actually translate that into action. And my whole theory of change and my philosophy is too that if we make the data publicly available and we bring attention to it, that people are now armed with this information and they can use that as a powerful tool for themselves. But yeah, I mean, again, I think in many senses, this also, I think, retrenches back into some of the systemic problems where you think about who actually has access to this knowledge and this information and access to technology to access the data and maps and to also understand it. And so one of the initiatives that I'm working on in the Triangle is trying to work with historically Black colleges who also are really, I think, more better positioned to reach these communities. And so how can we get this information to more hands and to tailor this information to communities in a way that will really reach them and resonate with them? So I think we need everybody working on strategies of how to translate this data into real action and power.
Fantastic. Thank you, Jennifer. Ron Ross, can you unmute yourself and enter the conversation here? Ron has worked on what we call our west side.
Historic West End. He's with the Air Keepers.
Yeah. Community advocate that has addressed infrastructure on freeways and sound barriers that in large part cut through minority communities. And he was here, but
I think he may have dropped off, but yeah, his question is quite good. So interested in available resources and technical support to address the heat island concerns by implementing green infrastructure, green walls on freeways, increased tree canopy, vegetation, etc.
Unfortunately, maybe he has departed. I do want to remind people, I've heard both sides of the technology, that the chat content may or may not be available to us once the session is closed. So let me encourage you to take a minute here to copy for yourself any of the content. The link that Dr. Shu put in for this preprint, if you're particularly interested in that. And then Mayor Roberts had put in a couple of links as well to some groups. Time for one more question.
I think Ron is back.
Well,
I'm
I
here.
see.
Okay.
Oh, hey man.
All
So
right,
why don't you pursue your comment?
Good, Angel. Nice meeting you. Enjoyed your presentation. A lot of good information. Again, a lot of the information we already know, we're aware of, and we need to look at some solutions to address those concerns. Just currently involved with Clean Air Carolina, we're attempting to seek some technical support and resources to try to create a green district, historic West End Green District, along our Beatties Ford Road corridor that is basically in the heart of Charlotte. and surrounded by freeways, industrial facilities, and the like. So the vision is to improve the air quality in our air. We've done some studies and so forth, and again, we're negatively impacted just by the where we're located. So we need to look at some ways that we can affect the air quality in a positive way. One way that we're looking at now, again, is by creation of a green district where we're wanting to increase tree canopy, looking at trying to do something with some green walls, additional, again, also tree canopy, that type of thing. And long-term range, as I mentioned, we would like to do something along the freeways. Our neighborhoods have been split by the freeways. And so if we can get some implementation of green walls on the sound barrier walls and that type of thing, again, that would have a positive effect on the air quality in our neighborhoods. And just as a point of reference for that, to me, that green infrastructure is a very big representation of the people that basically had to relocate from those areas. We had no say-so in it due to eminent domain. We were forced to leave that area that is now occupied by a toll road now as well. So it just gets worse and worse. So that's where we are and what we want to try to get some solutions to. Rather than continue talking about it, we need some solutions to rectify the problem.
Well, I really look forward to that. My parents recently relocated to Charlotte, and my younger sister has been living there for more than a decade. So I've been spending more time in Charlotte. So I think the plan, is exactly about framing some of these objectives in terms of co-benefit. So when there's these green districts, not only is it good for social cohesion and promoting some public safety, but then also you're achieving air quality and then also climate benefits as well. So, I think you could really check a lot of boxes with these plans. So that's really exciting. And I really look forward to keeping on tabs of how it progresses. And yeah, let me know if I can help. I think Jennifer put some on cooler cities. And so, yeah, I'm definitely going to check some of those out as well. And yeah, we're planning on getting even more high resolution with our data to get even more specific, and then also wanting to look at some of the benefits of some of these interventions. So when you do increase tree canopy or have like white roofs, for example, like New York City, right, they have a white roofs campaign to increase the reflectivity of their roofs and to reflect more of the heat. And so green roofs also is another popular policy option. And so, yeah, we're interested scientific perspective of trying to understand what are the actual climate benefits of these different policies, and so hopefully that'll be useful for cities as well.
Great, definitely. I'll connect with you, and upon one of your visits, we'll have to definitely take a little tour and so forth as well. So
that would be amazing. I would love that.
All right.
Thank you.
Thank you.
That would be amazing. I had the pleasure to meet Ron a couple times, and I put him in the authentic category. Dr. Hsu, we're a little bit over. I know you both, you had to already are probably late for your next event. Very stimulating, obviously very important work, highly interrelated to the topics that we've heard about the last couple of days. That might point to some substantive policy changes that we've all been, that we have all desired at so many levels. So I thank everyone for being here. I hope the day and a half and a little more has been worthwhile. Mr. Whalen, I think we exit out to the last round of presentations for the conference.
Yep, everyone can return to Whova and find their next breakout session to enter into. So thank you everyone so much for joining us.
Thanks everyone.
Thank you.